Okay, second day of 7.4, and today we're going to talk about how do you solve trig functions in quadratic form, or those that cannot be solved algebraically, and how do you even recognize those. So we'll start with example 3. We're going to solve algebraically. Cosine squared theta plus sine theta plus 1 equals 0. And they give us some domain restrictions. So theta is an element within negative 90 to 270 degrees. And we're not going to include 270 degrees in that. Okay, so starting with my equation. I notice that it's squared. I also notice that I've got a cosine and a sine, but I don't have any sine here. So I'm thinking to myself, I probably need to change that into something equivalent that includes a sine. So cosine squared is the same thing as 1 minus sine squared, just getting that from our trig identity, or our Pythagorean identity. So plus sine theta plus 1. So instead of cosine squared, I'm using the 1 minus sine squared. Okay, now I'm going to combine any like terms. So I'll have because I've got a positive 1 and a positive 1. I personally don't like a negative out here, so I'm going to factor that out. And now I'm going to focus on this part, and I'm going to factor it. You could also use the quadratic formula if you end up with something that is not factorable. But for me, I'm going to go ahead and factor. So, because I can see that this is factorable. I know that my first terms need to be sine theta. My last terms need to be factors of 2. I want a negative middle term, so my inners and my outers have to add to give me a negative. So there it is. Now I'm going to take each of these factors and set them equal to 0. Solving for each of them, I get that sine theta equals negative 1, or sine theta equals 2. But think back to everything that you know about sine, even like the parent graph of sine. What is the maximum output that we can have for any input into the sine function? It's 1, right? If you think about your sine graph, it looks something like this, right? Where our maximum output was always 1. So having an output of 2 is not in the range. So this is not in range. So we don't need to worry about that one. That's not going to work for us. So we're just going to continue with sine theta being negative 1, which we know, right? Our outputs down here always end up the smallest as negative 1. So that's definitely in the range. You know, and you can really do this in your head. So sine of what angle will give you negative 1? Well, that's 270 degrees. Going back up to our domain here, 270 degrees is not included. But what's another way to say 270 degrees? 270 degrees is here, right? And that's where sine is negative 1. It could also be negative 90. Okay, but let me show you how to do that using your arcsine. Okay, so solving for this, I'm going to end up with theta equals arcsine of negative 1. So that means then that that'll be sine inverse of negative 1 plus 360 degrees. Oh, 360. Oh, that's all right. Whatever. Or the supplement to that. Provided that it falls within our domain. All right, so let's see. So if you actually plug this into your calculator, I believe this one would give you negative 90 degrees. Let me just double check that. Let's find my calculator. Yeah, so I'm getting negative 90 degrees there. So this one's actually negative 90 degrees. If we add 360 to that, so let's see, so here I would get theta equals negative 90 degrees. Adding 360 to that gives me 270, and again, 270 is not in our domain. So then taking 180 and subtracting a negative 90, again, is going to give us 270. So I think our only answer is negative 90 degrees. And again, if you get some of these and they're very confusing to you, then you can use the quadratic formula. You'd have to think about A, B, and C. So let me look at what we have here. So our A here, sine squared theta, that's like our x squared. So your coefficient is 1. Here your coefficient is negative 1, and your constant is negative 2. Okay, so you can always use quadratic formula as well. I try to factor as often as I possibly can. To me, that's easier. And then the last example that we're going to do, example 4, we're going to solve 0.2x plus sine of x equals 2 for all real values of x. All right, so let me take you to, should I close my textbook? I might have closed my textbook. I did. Okay, well, we're not going to use that textbook, so sorry about that. Oops, you don't care about that either. Okay, so I'm going to just show you in my textbook, because we've got a problem here. This is going to be really challenging. X is the input of a sine function. The only way to undo that is to do arcsine or sine inverse. Here, I could divide by 0.2. That's not going to help me here. So how am I going to combine these x's? Well, guess what? It can't happen. So this is page 361. Okay, and it straight out says some trig equations cannot be solved algebraically. This is often true if the variable appears both transcendentally, which means it's in the argument of a non-algebraic function such as sine of x, and in algebraic expression. Okay, so and in an algebra, that's exactly what we have here. We've got a sine function and an algebraic expression, both of them having an input of x. There's going to be no way that I'm going to be able to solve that algebraically. That's okay. How can we do it? We can solve it graphically. No problem. So basically, you're going to have this part right here be y1, and this part right here be y2. You go on your calculator, and I highly recommend that you do this with me. Make sure that your window, let's see, do they give us any values here? Oh, they don't. Make sure your window goes to at least 15. I think that should be good. X equals 15 should be your maximum. And then I graph it. Oh, what's my problem here? So x, I'm doing this on purpose, by the way. No, I'm not. I'm just kidding. X means that I should be talking about radians, not degrees. If it was theta in this textbook, that's not always true. But if it was in theta in this textbook, then we would know it was degrees. So I think I need to be in radians. Okay, so let's try that one more time. Oh, there it is. And you can see that there are 3 places here that this intersects. Now, actually, let me make my window go a little bit bigger. Just to show you. Eventually, it stops touching it, right? It only touches it in 3 places. So you can calculate those using your second trace. And then we'll calculate an intersect. Oh, there's graph 1, graph 2, best guess. Great. I get one of my values being 12.127. How about that? And there are 2 more back behind it. And I'm just going to go ahead and give those to you. Or actually, they're just right here in the textbook. I mean, you can You can see it. I'm just doing example 4 from the textbook. So we've got 6.94 and 9.28 are also going to be 2 more that we would get. There they are.